All right, guys. I'm going to record this video, but I'm going to try to do class live also. So I'm not going to actually write on the packet, but I just wanted to show you that I have it here. But I'm going to go through each of these examples with you. I'm just going to do it on a piece of notebook paper, but this is the note paper. It should say 7-7 at the top, and what we're going to do is solve radical equations. So let me just grab my notebook paper real quick. The very top of it, in the blank, it says a blank is an equation that has a variable in the radicand or has a variable with a rational exponent, and all I want you to put in there is a radical equation. So we're going to focus today on equations that have square roots or square roots, cube, any type of a root. We'll do rational exponent equations tomorrow. So to solve any radical equation, what you want to do, you want to isolate the radical. Then you want to take both sides to the power of the index. So you want to get the radical expression by itself, and then you want to take and raise each side to the power of the index. So what I mean by that, like if you're doing a square root, then you're going to raise it to the power of 2. All right, so your letter A, we're just going to isolate the radical. So get rid of any addition or subtraction first. So the first thing I'm going to do is move that 10 to the other side of the equation. And I've got 2 times the square root of 5x plus 1 equals 12, trying to isolate that radical. So go ahead and divide by 2 to get rid of that in front of the radical. Get this totally alone. 5x plus 1, that's equal to 6. And then what you want to do once you've got your radical isolated is we're going to cancel it out, and I'm going to square both sides. All right, so I get 5x plus 1 equal to 36. From there, we're just solving an equation. You're going to subtract 1. So I'm going to get 5x is equal to 35. X is equal to 7. And any of these questions, we should really check the answers. We're going to get into that more on the back. But if I plug in 7 to the original problem, or really if you want to just back it up and plug it in right here, where we had the radical by itself, that would be sufficient to check. But 7 should be my answer for that first example. All right, in the second example, you got a cube root, so I'm going to do the same thing. I'm going to isolate the radical, so I'm going to get rid of any addition or subtraction outside that radical first. So I'm going to add 10 to both sides. That'll give me the cube root of 2x plus 1 equal to 5. Once you've got that radical isolated, this is just a hair different because this is a cube root, so we're going to take both sides to the third power to cancel that out. What I'll have left over, just whatever's under the radical. 5 to the third power is 125, and then we're just solving an equation from there. I'm going to subtract 1 from both sides. I'm going to get 2x is equal to 124. Divide by 2, and we should get 62 as our answer there. Okay, letter C there just looks a little different, but you're going to take the same steps and isolate the radical. So get rid of any addition or subtraction. Do not add that 4 and 6 together there, okay? So the 4 is being multiplied by the square root of 6. I would say that would be a really common mistake. So be careful, don't do that. Move the 6, and you're going to have that 4 in front of the radical. We're going to have 4 times the square root of x is equal to 44. And then what I want to do to get rid of the 4 is divide by 4. So we're going to get, oops, forgive me, square root of x is equal to 11, okay? Then all we have to do to cancel square root out, the index is 2, so we square both sides. And here, x, 11 squared is 121, and that's going to be my answer. Okay. Now, letter D is kind of interesting here. I want to isolate the radical, which it's already isolated. The thing is, on the other side of the equation, I actually have an expression. So I'm going to cancel this radical by squaring both sides. So over here, I'm going to get x squared plus 3. Now, this is, I know I keep trying to say this to you guys, so like a little star here. remember, you cannot distribute this exponent anytime there's adding or subtracting. Not good. Okay, when you square something, it means you multiply it by itself. So this problem is actually going to require a little FOIL here. Or you can draw a box if you prefer a box. I just think of it as a double distributive property. So x times x, I'm going to get x squared plus an x plus another x, and then 1 times 1 is 1. So completely simplified here, you'd get x squared plus 2x plus 1. And then from there, we're going to try to get x by itself. Now, in this particular question, if I try to get all the x squareds on one side, you have 1x squared on both sides of the equation. These actually end up canceling each other out. We'll deal with the quadratic on the back here, but my equation is really 3 equals 2x plus 1. Just going to subtract 1 here. 2 is equal to 2x, and if I divide there both sides by 2, that means x has to be 1 for my answer. Alright, and then the last part of example 1, this letter E, I actually had 2 radicals in the problem here, so to isolate the radicals, the easiest thing I can tell you to do, put 1 on one side of the equation and 1 on the other, and literally all I'm going to do, I'm going to add this 3 times the square root of x minus 5. I'm just going to add it to the other side of the equation. The other side of the equation is actually just 0. So I'd have this 3 is now positive because I'm adding it to the other side. Now, I can't really isolate this radical any further than I already have, so I'm not going to be able to divide by 3. So what you're going to do in this case, you're still going to cancel the radical. This is a square root. What we're going to do is we're going to square both sides to cancel both radicals. Okay, all that's going to happen over here, we're just going to get 4x minus 10, the square root and the squared cancel each other out. This is a little tricky. I actually have a product here. I have 3 times this radical, so when I square this, I need to square the product. So I'm going to write out kind of maybe an extra step here, but I'm squaring the 3, and then I have this square root of x minus 5, and that's going to be squared. So this is going to be 4x minus 10 equals 9. Now, the square root and squared here do cancel each other out, but I would keep that in parentheses because you're just going to need to distribute that 3 squared, which is where I got the 9. And so I'm going to get 9x minus 45, 4x minus 10. There's different ways you could solve this. If it's me, I like to try to keep my variable positive. So I would subtract 4x from both sides there. So I get negative 10 equals 5x minus 45. Add that 45 to the other side. And I'm going to get 35 is equal to 5x. And then ultimately divide by 5 there. And my answer will end up, oh, sorry, I'm not on screen. Answer will end up being 7. All right, on the next page, the next thing you guys are going to see is the words extraneous solutions, and add the S there for my paper. Basically the definition of an extraneous solution, and you guys will see the word extra literally in the word extraneous. So extra solution is what that is. An extraneous solution just means that you've done everything totally right algebraically, but your answer doesn't actually work in the original problem. This can happen in various cases. Most commonly, it can happen in absolute value equations. It can happen in these radical equations, and we'll get into this in a second, like which ones should you be looking at. So you just got to make sure to check your answers to these questions, but I'm going to get into this in a second. The main thing you want to remember today, though, when you're doing this, for our purposes, since we're working with some radical equations, you're not going to have a square root that's going to be equal to a negative number. So if that happens as you're going to go through here and check these, just look at that and you did the algebra totally correctly, but the original problem might be incorrect if you plug the value back in. So you just got to check, and I'll show you in these next couple examples what to look for. All right, so in example 2, the first part, I have this equation, square root of 7x plus 8 equals 2. Now, First thing I would do is try to isolate the radical. I have the square root of 7x, and that's going to be equal to -6. Sorry, not doing a good job writing the sevens today. Now, when you look at this, now I know immediately that this is no solution right now from looking at this problem, because I know I don't have a negative out in front here, so if I'm going to take a square root, I'm not going to get a negative number. If you don't know that, that's okay. Let me just walk you through what the problem would look like. Once you've got the radical isolated, that is where you would want to plug back in to check your answer. So like right in this step right here, once you've got that radical isolated, I'm going to show you when I plug this answer back in that I get that it's not going to work. Okay, if I'm solving this correctly, to get rid of the square root, we're going to square both sides. Now, this is where you have the potential to introduce an extraneous solution, because when I square this -6, it actually becomes positive 36. And then I would divide both sides by 7, and my potential answer here would be 36 over 7. Now, if you guys plug this back in to check, again, I would recommend, you can plug it into the original problem. I would plug it in right where you had your radical isolated. That's the easiest place. So if I plug that in, I have 7, and in place of the x, I do 36 over 7. And that's supposed to be equal to -6. That's what I'm trying to check out there. If you actually multiply this, what happens here is the 7's cancel. So I get square root of 36 equals -6. That's not true, because the square root of 36 is equal to +6. So that's what the problem is. So my potential this was my potential answer here, but because it doesn't work, I actually have to say here, I have no solution. There's no way I can solve that equation and get a real number answer. So for part A, no solution there. Okay, now I'm going to try this one. I already have my radical isolated here, and so we're going to square both sides. And again, when you square things, the potential for that extraneous solution gets entered into the equation, just like the last problem, because when you square a negative, it can make it a positive, and that can kind of mess stuff up. On this side, I just have 3x plus 10. On the other side, you're going to have x squared. Now, we haven't had a question like this, but what I want to have you do here is set this equal to 0, and here's what I would recommend. Keep your squared term positive to make it easier to do. So when I do that, I'm going to subtract 3x, and I'm going to subtract that 10 from both sides. Okay, now this is completely your choice. I'm going to give you guys questions that you can either factor. I'll let you have all the questions. You'll be able to factor, so you'll have the choice, but you can factor this or use the quadratic formula to solve. But I have the potential for 2 answers here. So if you haven't done this in a minute, which I don't think we have, what I'm looking for, oh, oops, I'm off my paper. I need, for this question, 2 numbers that multiply to give me -10, and to give me the number in the middle, which is -3. Both of these factors should start with an x. X times x will give me back the x squared. To fill in the factors, I just have to fit both of these requirements. Multiply to give me the -10, add to get me the -3. Only 2 numbers will fit both those requirements. We're going to do -5 and 2, -5 plus 2. You don't have to write that out, but I just like to check. So x minus 5, x plus 2. Doesn't matter the order that you put them in. Now the actual answers to the question, if you guys remember, is what would you plug in for x to make this 0? So this guy would be +5. This guy would be -2. Now to check my answers, we already had the radical isolated in the problem the way it was given to us, so I'd plug them back into the original problem there. If you plug in 5, 3 times 5 is going to be 15 plus 10. We get 25. Square root of 25 is 5. So this is golden. Now, -2. You cannot have a square root equal to a negative number. If you plug this back in, we're going to end up -2 there on that, we're going to end up with 4 under the square root, but this will be equal to -2. That cannot happen. So 5 is my answer. That -2 is going to be extraneous. So I would just use 5 as my answer there. This one actually had no solution at all. So it just kind of depends on the question. You might have 2 answers, you might have 1 answer, you might have no answer that works. It's really dependent on you making sure to check. All right, let's slide this up. I got 2 more questions in example 2 on the back there. So this is going to be super similar to the one we just did. We've already got our radical isolated. This is going to create a quadratic. I'm going to square both sides to get rid of that square root. I get -5x minus 6 equals x squared. Again, I'm going to set this equal to 0, and I'm going to keep that squared term positive just to make it easier on me to factor here. You can also solve this using the quadratic formula if that's your preference. Totally up to you, but any of the questions that you guys are going to see on this will be factorable. Alright, so I gotta multiply, a times c would be 1 times 6, so I gotta multiply to get 6, add to get the b value, which is going to be 5. Only 2 numbers that fit both of the requirements there, 3 times 2, 3 plus 2. So to fill these in, one's a plus 3, one's a plus 2, totally doesn't matter the order. And my 2 potential answers here, -3, -2. Okay, now you might notice this right away, but again, I cannot have a square root equal to a negative. So in the original problem, before I squared that, we're going to have that equal to -3, we're going to have that equal to -2. Neither one of these answers works. If you want to go through and write it out, I would be happy to do that. If I want to check that -3, this is what I'm checking. If I plug that in there, under your square root, this is going to end up being 15 minus 6, which is 9. Is that equal to -3? No. Square root of 9 is equal to +3, so that's why that doesn't work. And you'd have a similar argument if you plugged in the -2. So those 2 numbers are not going to work in that original problem. Okay, now I got one more. Again, this is going to create a quadratic, but the first thing I got to do actually in this question, the last problem here, I got to get the radical alone. So to do that, I just need to move this 5 real quick to the other side. So we get 3x plus 13, and then this would be x plus 5. Now, this is going to be kind of similar to a question on the front, where we're going to have to FOIL. So this is just going to be 3x plus 13, square root and squared cancel each other out. Do not distribute this. Don't. It's squaring. Anytime there's adding or subtracting in there, you got to do multiplication. Okay, so this is just going to stay 3x plus 13. I'm going to get x squared plus 5x plus another 5x plus 25 there. Oop, I'm off the paper. Alright, so I got 3x plus 13, x squared plus 10x plus 25. Again, I would set that equal to 0. Keep your squared term positive if you want to factor. If you want to use quadratic formula, you can do whatever you want, but I'm going to try to factor because that's a little faster for me. Let's see. 10x minus 3x, we got 7x. 25 minus 13, we've got 12. All right, so my possible answers here, you got to factor it. Oop. And I got to multiply here to get 12, and I got to add to get the number in the middle, which is 7. So I got two numbers to do that there, 3 times 4 and 3 plus 4. So there's my factored form. Now, my 2 answers, potential answers here, -3, -4. Now, just because it's negative doesn't automatically mean it's extraneous. Like I had that happen here, but that's just because this is equal to x. If you guys look back at this problem, and here's where I would plug it in, where we isolated the radical. If you plug in -3 here, right? -3 plus 5, that is a positive number. -4, if I plug it in here, or if you plug it into the original, you'll be okay, because if I plug that in, that'll be positive. Both of these numbers are actually going to work here, but let me just write it out so you guys can see. I'm going to scooch this up so I have some space. If I plug in -3, right, we had 3 times -3 plus 13, that was under the square root. I'm checking this. This was x plus 5, so that would be -3 plus 5. I'm plugging it in right here. If this is the case, this is going to be -9 plus 13, which is 4, and this is going to be -3 plus 5, which is 2. This is true. The square root of 4 is equal to +2. So that -3, that totally works. And we're good here. Now, if you want to go ahead and check the -4, you're going to see the same thing. This is a square root. 3 times -4 plus 13. That'll be the square root of 1. The other side of that equation would be -4 plus 5, and that is also equal to 1. Both of those are positive, so both of these answers work. So you kind of got a little mix of everything on the back here. Here, both solutions worked. This one is no solution. Neither one of them worked. Backing it up here. In this situation, one of the answers worked and one of them was extraneous. And then here, my only answer that was my potential answer was extraneous, so that has no solution. So make sure you go through and check all your answers, especially if you have a square root equal to a negative. Make sure you check.